Start, sir. Start.
Hello, viewers. Welcome to the participant of the NPTEL course, Gear and Gear Unit Design, Theory and Practice, NPTEL course. This is yesterday, I think you have completed all 8-week lectures, and today is the second online discussion session. So, first discussion session was on 27th March. The question I received by that time, I have discussed all. However, some point needs more clarifications. I think all of you have received what I have discussed, but I would like to discuss on one or two questions there. Okay. So I will do that first, and then today I have received another 9-10 questions that I also discussed. And during this period, if you have any questions, you are free to write. You can put it in the forum, and that will be received. If I cannot answer today in this session, definitely I will answer. Also, what I will answer or what I will discuss today, that I shall send to you on writing form, maybe tomorrow or day after tomorrow, within 2-3 days. Okay, so let me start the discussion. The first one question which I discussed last time, but I think it needs more clarifications. So I will discuss once again. The question was about the working stress of the gear. That is in the second week lecture. Maybe this is in the third or fourth lecture of the second week. It was that in the gear formula, the module calculation, why you are estimating the module. If you remember, the equation is module is cube root of twice into torque of cos of helix angle, this is of helical gear, divided by, denominator it is that S0, which is working stress, into CV, velocity factor, divided by CW, is the wear load factor. That whole that stress value into the width factor of the gear. Y is the formative modified wish for factor, and Z is the number of teeth. Now, in that formula S0, that is what should be allowable working stress of the material. For that, in calculation, I have shown that it is S0. S0 is equal to S yield divided by, that means yield strength divided by 2.5. But one of you have mentioned that somewhere I have also said it is ultimate strength divided by 2.5. I think somewhere maybe due to slip of time, I have made it. In calculation, I have shown it is yield strength by 2.5. Now, you may ask, or what you have raised correctly, that shall we always consider that stress value for the gear design? Answer is definitely no. Actually, what I have presented in this gear design course, that is very general approach. That is very basic approach. That is for the beginners. That is, if someone wants to design gear, how he should approach. Now, in real design, what you will find that suppose you have joined in an organization who are designing gears. First of all, you will find that they have their own standard. They will recommend what should be the working stress value, what should be the formula, and what should be the working stress value there, depending on load condition, application, many various factors are there. Now, say I shall give some example. Say, for example, you have joined a famous gear manufacturing company in here is Flanders, or you have joined in Allenbury, or you have joined in Elecon Gears, etc. You will find they have their own standard, but those standards are based on mainly the standards of the country and standards of various countries. Say AGMA is the USA standards, and similarly Germany is having their own standard, Japan is having their own standard. Following those, British standard is there. Following those, we have made our own standard. That means if you would like to design some gears, if no data is available, what should be the stress value for what material, then you can follow the standards. You can follow the Indian standards. You will find a book, standard booklet. From there, it is recommended what formula you should use, what stress value you should use. But the question is that we cannot have all the information together. So, if you would like to critically design, then in that case, you should have some experience. You should know what are the loads factor, how the load are acting on that. Okay, and from there you will find the what stress you should consider. Okay. Now, in my approach or the fundamental approach, what I have mentioned that S0 should be some value, so some factor of safety. You should consider some factor of safety, and you should divide the initial strain by that factor. Or even if you consider the ultimate strain, divide by some factor. Now, here I would like to say that why we are dividing by the factor. Now, if you follow the book, then you will find there is a discussion on that, how to consider a working space for a particular design for ductile materials. I will refer, I have already mentioned that name of the book, that is Design of Machine Elements by M.F. Sports. If you go to chapter 2, there you will find a section, Ductile Materials with Combined Steady and Alternating Stress. And there you will find the Soderberg equation, which is recommending what should be the working stress of material. Okay. In that formula, you will find they have considered a factor of safety. And if you divide the yield strength by that factor of safety, that can be taken as a working strength of the material. Now, here again, what you are going to design. Suppose you are going to design a structure, you are considering the spaces of structural steel. There you have to find what type of loading and what type of failure, etc. occurs. And for that you will find that even if the stress value, maximum stress value is reached to a certain value, say it is 200 megapascal, factor of safety will be different. In case of gear, which is rotating member, and their load conditions are different. So this means that for different component design, this factor of safety may be different. Now, I think you have the knowledge. What is yield strength? Yield strength is up to the material. If you go on loading, that stress value is such that at that point, whatever elongation is there, if you remove the load, again it will come back to the original position. Beyond that, it will the elongation, whatever elongation will be there, it will not be come to this point. And then there will be a ultimate strain where it will fail. Actually, failure strain is again less than the ultimate strain. Now there is another strain is called endurance. So endurance strain, which is, say, if I put SY for yield strain, SU for ultimate strain, then SEN. SEN is recommended for some materials, available for some materials. If you look into the standards or if you look into the manufacturer's catalog, you will find it is given. But if it is not even given for ductile steel material, you can take around 0.5 to 0.45 of ultimate, ultimate, and that will again will be more than a strain. Okay, this means that if you apply a alternating load from 0 to that value, after 10 to the power 6 cycles, that material will fail. It will simply fail. It will tear off. Okay. Now, ultimately, what we should be consider that our design stress value, what design strain we are considering, that should be below yield strain, but how much? Now here, the important issue is that what you are going to design. For example, you are going to design a general purpose gear. Then normally, in that case, load factors may not be known very much. You do not know what is the operating cycle. You do not know how much impact load will come. If those data are available at the time of design, you can incorporate, you can find out the stress factor. Otherwise, what you have to do, you have to make the design on the basis of some factors. Now, there, the manufacturer, they will dictate what should be the factor. What I have shown here, that in average, suppose you have to design a gearbox, somebody has asked you to design for general purpose, and he is not much bothered about the load. He wants only that we have to design such a gearbox that it should last very long. In that case, 2.5 value factor of safety is very good to find out S0. That means S0 is equal to S yield divided by 2.5. Now, if you look into this, our example, what we have considered that for pinion design, we have taken a material EN19, which is again hardened up to 300 to 340. We should know that with the heat treatment, the strain is slightly modified, not very much, but it is modified. Now, if it is raised up to 300 to 340, in that case, ultimate strain is 940 megapascal and yield strain is 600 megapascal. And if you consider it is divided by 2.5, then we are getting around 200. That is SY divided by 2.5 is close to 240. It is coming around 240. Okay, 240 is the value. So we will take 240 megapascal for the design of the gears. Now, why we have taken like this? Say in here, in steady stress may be less than that, but sometimes stress will increase due to some impact load that may even go a little higher than its strength. Then it is dangerous. So we are considering that load will never exceed at least the endurance limit. Endurance strain will be around, in this case, yield strain divided by 1.4. It is 0.45 into ultimate strain. So in this case, it will be yield strain divided by 1.4. So we are staying below that. to make our design safe. This is for gear, not for others. But in this case, EN18 we have used for gear as well as for shaft. So for shaft also working stress we are taking the same. So I have cleared a little bit that how we are considering. But again I mentioned, when you will really work on gear design, you have to follow the standards or the manufacturer standards, or even those who are generating gear generating machines, they have their standards. So you have to follow those. And if you had to design some precision gears, say for example automobile gears or machine tool gears is not very much load transmitting, but aircraft gear where the safety is main issue, but as well as it should not be heavy. In that case, this value factor of safety will be less. But in that case, design is verified, redesigned, modified using the say finite element techniques or any other stress analysis, detailed stress analysis technique, that is to optimize the size. There you will find that factor of safety may be 1.5, 1.2, 1.3. Okay. So I think you have got the message. What I have shown, that is only general purpose design. So you will receive this note what I have discussed today. Now next question, I am going to the next question. Now in mounting the gears on the shaft or any other component, what is done, either keyway is there, say pulley, you are assembling a pulley, you are assembling a coupling. Key are used, normally one key, but you will also find that splines are used. Two key are used, but very rare. Normally one key is used, or you will find the spline. Normally general purpose gearbox design, the keyway is enough, but in case of automobiles, in case of aircraft, in case of machine tools, to make the size optimum, splines are used. Now, what are splines? Splines you may call it is multiple key. These are no separate key is used. In case of spline, you will find the male serration. It is like a gear. Splines almost like a gear key. Is sometimes involved splines are there. This is gear kit. Now maybe on a shaft where it is being mounted, it might be 6, it might be 8, it might be 12. Okay, that means 12 key you are using. In that case, definitely thickness of that groove, depth of that groove is much less than single key. Okay. And this will be male component on the shaft and female component on the gear or maybe pulley, maybe your coupling, etc. will be there. And then the load is being divided by the number of that team. So that is why the depth is less. How it is fitted? It is normally will be tight between the teeth. Okay. And for the location, it will usually on the shaft groove, and what is the lowest diameter in the groove, and the diameter, whole diameter of the component being fitted is equal. They are with some tolerance so that easily you can push. So if you try to fit a spline, you will find that you have to put some thrust load or fitting. You have to push it. But you should remember, this is on the inside hole of the mating component, and the staff are usually of equal. There is a very little, whatever thrust you are being needed to assemble, that is on the stress is being developed between the splines, between the teeth of the mating components. Okay. Now, where the splines are used and where the teeth. Normally, after designing the gear, pinion, etc., you are thinking of fixing the component. Now, you may find if you want to use one key, okay, this is again on the shaft diameter, this key is recommended. What will be the thickness, what will be the width. Now, you may find that single key, if you want to use the single key, either the length is very high or might be the depth is very high, or you have to increase the shaft diameter, etc. Now, length of the half, usually for fixing this, it is 1.2 to 1.5 is good enough of the shaft diameter. Now, if you want to use 2 times, sometimes you will not get any space. Or for precision gears, you do not want to increase the shaft diameter. Better you go for spline. Okay. Now, another issue is there, which is very important. In case of spline, as it is distributed, the groups are distributed. The stress concentration factor is less than the single key group. Okay, so on at the key section or the spline section, the developed stress will be more. Suppose the shaft diameter remains same, and you are using single K or you are using spline, you will find the stress concentration factor for single K is more. So these are the issues you have to consider for the QA or splines. Normal case, general purpose design, you need not go for spline. It will be expensive, definitely. Then a QA category. So I think you have got the answer. Next question is that what should we consider the diameter of input shaft at pinion? What is the diameter of input shaft at pinion? That means what I understand, suppose you are considering input shaft having the pinion integral with the shaft, then what should be the input end diameter? If that is your question, then first I should say that if the pinion is integral, then minimum shaft diameter at the pinion is the root diameter of the gear of the pinion. Root diameter of the pinion. Okay. So suppose it is root diameter is coming 48 millimeter. Okay. Now input end will be the pinion end. In that case, from that 48, first of all, where you are cutting the gears, the addendum circle, the blank when you are preparing, and then root diameter will be 48. So after that, you have to make a slight step down. Let us consider it is 47.5. And after that, you have to consider a bearing is sitting there, and bearing inner race, the inner race collar end should touch the shaft step. It should be able to take the axial load. So you will find that bearing again, inner race is having some corner radius. So considering that, you will find at least you have to go 7 millimeters down to that. So 47.5 minus 7 millimeter, you are coming 40.5 millimeter. So bearing you should use 40 millimeter. You can use the 40 millimeter bearing. Okay. Now you can put the bearing. After the bearing you cannot push for the shaft input end. You have to bearing width, say suppose it is 20 millimeter. So after that step, you have to take around 20 millimeter or even less, 18 millimeter, because after that coupling etc. will be there. So for that 40, and again after that there will be seal. So if you use the 40 diameter for the shaft, maybe you will find that steel diameter is 38. So that step will be 38 millimeter. 40 with slightly minus you can use, but to lock the bearing sometimes in between the seal and there will be a circle also. Okay, so you can keep that portion is 40 for the sealing element, slightly down from the what is for bearing diameter, or maybe 38 is a good dimension. After that, you have to think of the coupling. So sealing element, then it is coming out of the gearbox through the bearing cover, and then you have to mount the coupling. So if I consider 38 for to put the coupling and that end also sitting on a shoulder, is touching the shoulder, maybe 35 is the shaft diameter. Okay, so this means that where your root diameter is 48, there your shaft diameter is maybe 30, 35. You can make it like this. But in case you cannot come down to that because for transmitting the torque you need more diameter. Sometimes the where the bearing is sitting, that might be that it is not below the root diameter, but it is maybe pitch circle diameter, and there a collar is put, and then your bearing you are using of 45 millimeter instead of 40, you are using 45. That you will learn when you will go for designing. Okay, so in that way, this is the design philosophy what I will explaining, what you have to consider. And now, if you think of the other side, then after that pinion, if it is an input shaft, which there is, then other side diameter also will be less. So this side, if 40 millimeter bearing, other side, even if you can go for 35 millimeter bearing, because that side load will be less. In case of intermediate shaft, where this pinion is there as well as gear is there, but there is not no input, no output side. So in that case, just you have to consider for the bearing in the pinion side is maybe 7 millimeter less than the screw diameter. Okay, 7 to 8 millimeter less than, you have to find out it should be the bearing diameter should be multiple of 5. In other side, after a little step, even if you can increase the diameter, but normally if diameter is decreased and there the gear is put. That means if your root diameter is 48, for putting the gear, there might be your shaft diameter on which the gear is sitting is maybe 45. And then other side you can use the 40 bearing. And for transmitting the axial load for gear half to the bearing inner race, you may use a special, it is a ring sort of thing. So which I have discussed in the detail design. I think you have got your answer. Okay. How to find out the shaft diameter. Okay. Now, next question is that now tooth correction. In tooth correction, we will not change pitch circle or pitch point. Now, this is, I don't know what you have interpreted. For S0 correction, for S0, that means no center distance change. If we consider no center distance change, we are considering only straight tooth spar here. We are not considering other here because this will be more complicated. So there will be no change in pitch point, no change in the pitch circle, only if it is a S0 correction. S0 correction is normally the pinion tooth thickness is increased and gear tooth thickness is decreased. That means amount of correction for the pinion and amount of correction for the gear is same, equal. One is plus, another is minus. Now, it is correction in case of pinion, the cutter is not allowed to go up to full depth. Some amount of X factor is there. In case of gear, it is otherwise more deepening. Okay. So looking into this, now your next question is that suppose if we increase the width of the cutter and then if we increase the addendum factors, then there is a question of gear topping, and then in that case the topping thickness will be very less, peaking will be there. Yes, those are there. So you can then truncate the height a little bit. So your addendum factor, where addendum factor is standard, is 1, and in that case, in fact, if you withdraw, it will increase also. So you have to calculate those. Normal recommendation, it should be 0.4 of module, but even if it's not there, it's acceptable. I will discuss further that point also. So you can definitely truncate it a little bit, and also in other gears, you can either add or truncate. And there will be more space at the root with the mating gear. It doesn't really matter much. The space is, in general, it is available. Sorry, it is required. So it will not matter much. So you have to take care of that. But if it is a S correction, in that case, your pitch point, pitch line, everything will change, pitch circle will change, the working pressure angle will change. But still there also, you have to think of this, how much will be the real addendum. Addendum may be more than 1, or it might be less than 1 also. Usually not less than 0.8, it should not go for. And if it is more than 1, better you keep at 1, and topping top, you can calculate what is the top thickness, and you can modify the design a little bit. But this is for very general purpose. You are talking the rack cutter, this will also lead to picking up to the air, right? I have discussed this point. We truncate the tooth tip to standard addendum size. Okay, even as I told, it might be standard addendum size or slightly less. Only you have to verify your contact ratio should be more than 1.4 for general purpose, 1.4. In special cases, you can come a little less, but it is never less than 1. Okay. So 1.4, keeping that, you can decide all of the factors. Okay. Now, next question is that, is it possible to have multiple lobes in harmonic drive? If yes, suppose if we have 3 lobe wave generator cam, then tooth difference between ring gear and flex gear should be multiple of 3. What advantage will it have over 2 lobe wave generating cam? Now, first of all, I would say, why 2 lobes are there? You can go for only single lobe, because single lobe is rotating, so it will work. But there is 2 important issues. One is that single lobe means it is the eccentric cam, so it will have its own dynamics. So best thing that you should have a mirror image of that. That means 2 lobes. This is one issue. Next issue is that there is deep interference, internal gear and external pinion, that should have minimum tooth difference to avoid deep interference. What is deep interference? Deep interference is that even if radially you can try to engage the teeth, in case of internal gear and external tooth gear, you have to assemble it from radial side. You may not be able to assemble from the radial side. You may not be able to assemble. Even will work. You have to assemble it from axles. Okay. Now, when you are trying to assemble an axle side, then you will find it is not going in. So, if the teeth difference is less, in case of 20 degrees starved teeth means 0.8 addendum factor of both pinion and gear. You'll find this value is 7. You should have 70. If you have 7 to difference, in that case you can assemble from axial side, but still you cannot assemble from the radial side. If you can assemble from the radial side, the difference is very high. The 22 difference, possibly you can assemble from the radial side. With the increase in pressure angle, say 30-degree system, this number is less. You can go up to 4 is the difference with 30-degree pressure angle system. But in harmonic drives, we are flexing this pinion. Actually, by flexing this pinion, involumetry is gone, but still it will work. And important issue is that with starved teeth, you can go for 2 teeth difference after flexing this inner pinion. So 2 lobes is important in that way. Now question is that if we go for 3 lobes, now increasing 3 lobes with 3 teeth difference, definitely it will work. But possibility of tooth interference will increase. But if we can manage with 3 lobes, then it will have more load carrying capacity because the load is being divided in by 3 teeth, 3 pairs of teeth. So size you can optimize. But again, if this is difference is 3, this means that you have to go for higher number of teeth to have the same transmission ratio. Because transmission ratio is always either number of teeth of the pinion or teeth of the gear if I divide it by the difference. So maximum you can get by 1. Difference is 1. So if you want to have 50 reduction ratio with your pinion is output, in that case, you have to go for pinion teeth is 100 and ring gear teeth is 102. But if the difference is 3, then you have to go for 150 teeth for the pinion and for the gear 153. So this is again maybe some assembly problem. Cost will increase. So this will not be good design, but theoretically it's possible, definitely possible. Now next question is that if minor deviation is there, that is if a very small non-involute part is coming in contact, will be some undercut and removal of material, would it still affect the motion and if running at low speed? Now the question is that usually this undercut will happen if the tooth number is below certain number. So mostly in case of pinion. So in case of pinion, this sort of undercut usually appears. Suppose the recommended tooth number for non-corrected gears 20-degree involute, it's 70. In case of straight spar. In case of helical gear with a helical angle around 15 degrees, you can come down to 16, 15, even if 14. Now, if you go for 14, say, you will find some undercut is there, but that undercut is below the dedendum. Say dedendum is 1.25, you may find it is at 1.1 or after 1.2, this undercut is there. Now, this undercut definitely will affect the stress concentration, but not severe. And your contact will never go beyond that because your addendum is 1. But suppose the undercut is such that you have taken 10 teeth, your undercut is such that it is from the pitch circle, standard pitch circle, it is at 0.9. Definitely your teeth will, the ear teeth will try to work at that portion. Now, there again, sometimes that teeth correction is given. Teeth is not exactly, so it may work, it may not hamper. Only the stress will be more. There will be some dynamics also, but usually not it is done. If you take 17 teeth, in case of 20-degree involute, straight spar gear, no correction, then your undercut is not there. If you take 16 teeth there and to design, make the design, there will be undercut, this will be more, but it will not affect gear performance because it is not below the 1 of addendum, at addendum side of the pinion. Okay, so that is, I think, briefly I have discussed this point. Again, another issue is there. My very high load transmission, you will find that involumetry is really cannot be maintained fully because your whole profile is being deflected. So for very high performance gear, you will find even if that profile modification is introduced to have better performance. It is somewhat like that. After deformation, it is behaving like an involute profile. Profile is slightly deviated from, but those are very complicated. Those are designed by the gear manufacturers or even by this. So you can calculate deformation, all you have to consider to find out those profiles. It is not an easy task. But if you had to really go for that, definitely you will learn how to do it and it can be done. Standards are available as well as you will know the technique how it can be done. Now, next question is that which paint is considered as slow speed application and high speed application? Now, the gears are applied for many applications. Say, for example, when it is a machine tool, it is rotating very high speed. If it is rotating a turbine, say, for example, in aircraft, it is rotating a impeller of the aircraft, right? In that case, you will find it is rotating very high speed. In case of other load transmitting unit, you may find that speed is very in the increasing scale. Now, when we should consider very high speed and when we should consider it a low speed? I would say that you will find, depending on the speed, the gear surface finish is required. So, pitch line velocity is one important issue. So, calculating on the pitch line velocity, if it is pitch line velocity is high, the surface finish will be very good. Now, that is again gear design, it is recommended. So, in terms of pitch line velocity, you will find some recommendations there. But in general, I will tell you that what should be the speed of the motor. Usually in general purpose motor or general purpose engine, you will find that it is around maybe the 1000 to 1500 for general purpose. Motor is like that, 1000 to 1500 or maybe 950 to 1450 like that. So that is normal speed, I would say. If the input speed of that your gearbox is more than that, suppose you are using an engine, say in that case it is more than 1500, then you should consider that is a high-speed input gearbox. Of course, the output side, it will be very less. And if you find that after that gearbox, you might be using another gearbox. Say, for example, one example is that rotary cement kiln, you know this very big drum, cement manufacturing, that is rotating. The drum is rotating. That on that drum, the gear which is being used, that is called guard gear, or consider the merry-go-round. It is rotating at very slow speed. In that case, you will find one gearbox from motor or from the engine. There is one gearbox is there, that is the main gearbox, and then there is a very auxiliary, another auxiliary gearbox. That auxiliary gearbox input might be 100 RPM, output might be one revolution per 15-20 minutes. One revolution per 15-20 minutes. In case of cement manufacturing, it's like that. In case of merry-go-round, it might be 2 RPM per minute. Sorry, otherwise, one revolution per 2 minutes or 3 minutes. So that gearbox is of slow speed. Now, in that slow speed, if the gear to surface is slightly not very polished, still it will work with less vibration. But your main gearbox, you need better surface finish. If you want to use in the machine tools, you need better surface finish. So those are high speed. So there is no exact definition for the gear. It is a high speed gear or low speed. We consider in that way. Okay. All machine tools gear you can consider high speed gears. All aircraft gears, precision gears, you may consider the high speed gears. And normal purpose, you can consider the general RPM or speed is general, nominal, whereas very slow speed application, you may consider this is that slow speed application. So I think I have somewhat given some idea. Now, next question is that to avoid peaking, we stop or truncate the gear. The limiting value of top land width is 0.4 module, which I have mentioned. Not I have, it is in the normal case gear is preferred that it should be 0.4 module. So should it be more than 0.4 module for more strength, right? If yes, then why did we accept a topping value of 1.163, which is smaller than 0.4 module? Now look, 0.4 is the general. There is no corrections. Usually you will get 0.4 module. If it is slightly less, doesn't matter. If it is slightly more, no matter. Now, if it is really less, suppose one value we have given 1.163, definitely there the tooth is having very less strain at that point. The tooth may break. Yeah, you are right. But if you look into this, how the load is being taken, the tooth profile, if you consider that, it is a parabolic load. So load will come from the teeth to the vertex of this parabolic shape, and it may not fail. And this is 1.163 where we are going. This is very rare. Perhaps this is for a corrected gear as well as to maintain the contact ratio, fulfilling the other condition of that gearing. Say this happens in case of internal gears and say maybe in harmonic drive and etc. Where the harmonic drives is not for very high load transmission, but it is for very high reduction and usually for precision drive. There is accepted. And also another issue is there. Say, suppose you are designing a air pump. In that case, tooth tip thickness is made usually less. There, the two mainly it is not very high torque, but the important is that pocket size of that gap, which is the chamber volume in case of gear pumps. So there you will find the tooth tip is less, and addendum factor is might be more than 1.1, more than one addendum factor, not start tip. Okay. Even if say suppose to reduce that, to increase the top thickness, if you truncate, but again truncation below one module, below 0.88 module is not usual. If you want to reduce due to some reason, there might have some reason, interference, etc. 0.7, okay, it is acceptable, but you should not go below that. Okay, so you have to make your decision there. What is the application? Whether you can go for that, you can check immediately the contract ratio. Usually, in an industry where you have to design a gear unit, you will find that you are using a software. When you are giving some value, modifying something, immediately it will check everything. So you did not worry about this design. So you, I think your what you wanted to know, that if it is more less than 0.4, what you should do? As I told, that you have to consider the specific design, and then you can verify your design to that. Okay. Now there is another question, the last question which I received before this session. That is, I am not understanding the direction of various forces acting in the gear unit. If possible, please explain. You see this, if I could show those, the load, how to estimate the load and other things, this figure together, which is available in the lectures. That is, I think, is week 2 and week 3 design lectures. Week 2 and week 3 lectures. If you go there, there are diagrams. In, say, for example, I think week 2 lectures, there are helical gear, helical spar gears, and bevel gear. I have shown the diagram. Now the question is that what should be the directions? First of all, say for example, if you consider the helical gear, then on tooth, considering the line of actions, a load is coming. You can resolve that load into 3 components. One component will go directly to what the SAT center, that is the radial load. Another is tangent to your pitch circle, or the circle where it is acting, pitch circle. We will consider from that. We resolve the force at each point. There, tangent to the pitch circle, which is the tangential load. And if it is helical gear, then there is an axial load also. You can resolve the loads using the formula given. But the question is that which direction is acting. Now you have to remember, say, pinion is driving. First, you should consider the pinion. It is driving. It is rotating clockwise. It is driving and rotating clockwise. That means you are going to your right hand direction. There is pinion is front of you, are going to right hand. Then it is, as it is driving, load is acting in the opposite direction. It is pushing something, so load is acting on the person direction. That means your tangential load direction will be opposite to that. It is opposing that motion. Okay. Now, if you come to the gear, in that case, your direction of rotation of the gear is anti-clockwise direction, but it is being driven, it is being pushed, so load is also in the same direction, the tangential load. Now, if you get the tangential load directions, so from that tangential load direction, you can find out the axial load direction in case of helical gear. That is most important. You have to find out that. Again, that depends on the direction of helical angle, direction of helix angle. So in that way, you can assess in which direction load is acting. Now, in case of spar gear, there will be no axial load. Now, it is very interesting in an intermediate shaft. What should be the direction of the helix of the gear and pinion? Say it is one pinion, one gear is there. Usually, what should be the direction of helix? If you consider the driver and driven and the direction of the load, you will find if the helix angle is given in the same direction, that means for both for the pinion and gear, it is both left hand or both right hand, then only your axial load will act in the opposite directions. So resultant axial load will be less. And you should remember, mating gear you will have always the direction of helix in the opposite. If for right hand helix pinion, your gear will be left hand helix gear. But on the intermediate shaft, they should have gear and pinion should have same direction of helix. So many people make the mistake there. They make the opposite, because if it is in the opposite directions, then perhaps the axial load will oppose each other and it will be this. But it is not that, because on the intermediate shaft, gear is driven and pinion is driver. Driver is pushing the load, so it will experience the load opposite to the direction of the motion, but which is driven, it is being pushed, so it will have the load in the direction of its motion. That you should remember. So I will send this note to you. Maybe it may take 2-3 days. So I do not have any other questions to that. In the meantime, if you have some question, do not hesitate to write, put in the forum. I will be in touch of the forum questions, and whatever questions you are giving, this I will definitely answer. Now, I take this opportunity to mention you something that our examination will be on 24th April or 26th April or something like that. So still another 14 days are there. So in between that, if you have some clarifications, definitely I will answer. But you should remember one thing. Already I have given you the notice. To pass this NPTEL course, yes, it is like that. You have to score, I think 25% is on your assignments. So whether you have completed all assignments or not, you have to score there at least perhaps the pass mark is 10 or 12 out of that. And here again you have to, for pass mark maybe 30 out of 75 or so. Only then you will get a pass certificate. Otherwise, suppose if you go the examination, if you get say 70 out of 75, but you have not done any assignment, in that case, you will not be able to pass certificate. Only at that you should remember. I do not know. I have given this notice whether you have done or not. Your assignments, scores, everything is with me. I will try my best if something can be modified. But in examination, as I would like to mention, best thing you should use some, if possible, that rough sheet where you can just mark the question and some calculation. You keep it with you, because sometimes you may find that calculation may not be directly help, but indirectly it will help, because in the question everywhere I have not given all the hints. So one hints may help in answering the other questions, because in this course, gradually you are going into deep, tough into tough.
Excuse me, sir.
Yes, please.
Time is over, sir.
Okay.
Time, sir.
So it is just 7. Thank you
Right,
very much. I think I have completed everything. So I thank all the participants as well as the NPTEL team. So this is the end of this session. Perhaps we will not meet in this online session. Okay, thank you very much.